Welcome back, Focus Learners, to another explainer. Right, so today we're basically gearing up to face the ultimate boss battle of the CompTIA A Core 1 exam. And yeah, that's Domain 5. We're talking hardware and network troubleshooting. And look, this isn't just about memorizing definitions. It's about, putting on your IT detective hat and solving real practical mysteries. Let's get you ready to absolutely conquer it.
Okay, let's dive right into this study map. First up, the 28% challenge. Then, the six-step method. Third, diagnosing hardware. Fourth, untangling networks. 5, mobile and printers. And finally, number 6, the final diagnostic check.
So starting with Section 1, the 28% challenge, or basically the real stakes of Domain 5.
Now, you've got to understand, this domain is completely different from the rest of the test. You literally can't just memorize your way through it. Domain 5 makes up a massive 28% of the entire Core 1 exam. Think about that. It is the single largest, most critical gatekeeper standing between you and getting certified. If you don't master troubleshooting, well, passing this exam is going to be incredibly tough.
Troubleshooting is a logical process of problem solving, not relying on guesswork. I love this quote because it perfectly highlights the exact mindset shift you need right now. The exam is going to throw symptoms at you, and it will relentlessly test your ability to systematically isolate the problem. It's testing if you can actually diagnose and fix faults, rather than just, throwing random parts at a computer and hoping for the best. This logical, step-by-step process, that's exactly how elite IT pros operate out in the wild.
Moving on to Section 2, the six-step method, which is really your ultimate troubleshooting cheat code.
Now, what's really interesting about this framework is how much you're going to rely on it. Even though CompTIA kind of stepped back from making you explicitly memorize these exact 6 steps in order, you absolutely 100% must apply this methodology to survive the performance-based questions. Right? So step 1, identify the problem. You got to gather your info. Step 2, establish a theory of probable cause. Question the obvious stuff first. Step 3, test that theory. And hey, if it fails, no big deal, just establish a new one. Step 4, establish a plan of action and actually implement the repair. Step 5, and this one is so crucial, verify full system functionality. Never just walk away. And finally, Step 6, document your findings and outcomes. The golden rule here, always verify and inspect before you start ripping out and replacing parts.
All right, Section 3, diagnosing hardware. We're talking motherboards, RAM, and power. Let's get right into the physical guts of the computer. The thing is, the computer is actually always trying to talk to you. You just need to know its language. When you boot up, it runs a power on self-test, or post. One beep, beautiful, everything's great. But if you hear multiple beeps, yeah, the motherboard is basically screaming that there's a major hardware failure, usually RAM or the CPU. Now, what if you get a totally blank screen? In that case, suspect the motherboard itself, maybe the graphics card, or a completely dead power supply. Oh, and if you're looking at a network storage array and see a glowing amber light instead of green, red alert, that is the universal warning that a drive is totally dead.
Okay, time for a little mystery scenario to test your instincts. Imagine a workstation powers up perfectly, but you hear this distinct clicking noise coming from inside the chassis. Then, exactly 5 minutes later, it just completely shuts down. Based on that CompTIA methodology we just talked about, what's the very first component you should check?
Well, if you guessed the CPU cooling fan, you hit the nail right on the head. This scenario is a perfect illustration of thermal throttling. See, if that fan stops spinning, which, by the way, is probably what's causing that clicking noise, the CPU gets incredibly hot, incredibly fast. To save itself from literally melting down, the motherboard just cuts the power, boom, system shuts down. That very specific 5-minute window before the crash points straight to a rapid overheating event.
Let's try another test, this time jumping over to network storage. You've got this high-performance workstation running a RAID 5 storage array, but users start complaining that accessing data has suddenly become painfully slow. You go inspect the physical machine, and sure enough, there's an amber indicator light glowing on one of the drives. So what exactly is going on here?
Basically, you're dealing with a degraded array. Remember, RAID 5 requires at least 3 drives, and it stripes data across them while creating parity bits. That amber light is confirming that one of those drives has totally kicked the bucket. So why is the network crawling? Because the system is actively struggling to instantly recreate the missing data on the fly, using those parity bits on the drives that are still alive. To fix it, you just pull the dead drive out, slide a brand new one in, and let the array rebuild itself.
That brings us to Section 4, untangling networks, IPs, cables, and connections.
This is our second major troubleshooting zone, looking at the invisible threads connecting all our gear. Now, here's a classic networking test scenario you are practically guaranteed to see on the exam. A user submits a ticket saying, "Hey, I have zero internet access." You open the command prompt, run an ipconfig check, and you see their IP address starts with 169.254. Why in the world did they get that specific address?
So the absolutely crucial point to remember here is that any address starting with 169.254 is an API-IP address. And what that means is the DHCP server, the machine whose entire job is to hand out IP addresses, completely failed to reach this computer. Because the computer didn't get an assignment, it just stubbornly assigned a private IP to itself. So your next troubleshooting step isn't to start messing with the user's computer, it's restarting the router or checking the actual connection to the DHCP server. Now, isolating the scope of a problem is honestly half the battle. Imagine this. A whole department reports an issue. They can access the local network printers perfectly fine. They can open files on the local shared server. But they cannot load a single external website on the internet. What piece of the puzzle is missing here?
The culprit in this scenario is definitely the default gateway. Since all the local resources are working just fine, we immediately know the internal network switches, the cables, and the local IP addresses are totally solid. But when traffic tries to leave that local network to go out to the wider internet, it just gets lost. The default gateway, which points your traffic to your router, is either misconfigured on the workstations or the router itself is just down.
And this brilliantly illustrates the difference between finding a problem and testing a problem. This is a distinction CompTIA absolutely loves to test you on when it comes to network tools. Say you have a massive, unlabeled bundle of cables and you desperately need to find where one specific wire ends up. For that, you use a toner probe, also known as a fox and hound. It literally sends an audible sound down the line. But if you already know you have the correct cable and you just want to make sure it's not broken inside or wired in correctly, that's when you plug it into a cable tester. Find the cable with the probe, test the cable with the tester.
Moving into Section 5, Mobile and Printers. Fixing peripherals. Welcome to the notoriously troublesome world of office printers. Honestly, they're the only devices that can actually smell fear. You are going to see printer questions on the exam, guaranteed. So here's a highly specific scenario for laser printers. A user prints a critical document. It comes out of the printer looking great, but when they grab it, the text easily smudges right off the paper and onto their hands. You've already swapped the toner, but it's still happening. What exact component has failed?
Their failed component is the fuser assembly. You really have to remember that toner isn't wet ink. It's basically this incredibly fine plastic dust. For it to stick to the page permanently, the fuser assembly has to get super hot to physically melt and press that plastic dust right into the paper fibers. If the fuser isn't heating up, the toner just sits loosely on the page, just waiting to be smudged off.
Now, let's consider this kind of tricky mobile scenario. You've got 50 identical company-issued tablets. Most are fine, but a few users complain that their wireless stylus pens are charging super inconsistently. Now, because the hardware and software are identical across the whole company, a firmware update isn't going to fix it. The catch here, it's environmental. A lot of times, users will go out and buy their own thick, third-party protective cases, and those cases are physically interfering with the short-range wireless charging connection on the side of the tablet. Always check the physical environment first.
And finally, Section 6. Final diagnostic check. You are ready. Well, you've navigated the hardware failures, untangled the IPs, and fixed those weird peripheral quirks. Passing Domain 5 isn't just about knowing what some random acronym stands for. It's really about mastering the mindset of a true IT troubleshooter. So, when you finally sit down for that exam, are you going to panic and rely on guesswork? Or are you going to methodically isolate the variables and let the symptoms guide you directly to the root cause? I know you've got the skills to do exactly that. Good luck out there, focused learners.